get us going on YouTube. There we go. We are all set for another episode of Insider's Guide to the Galaxy. Today,
so this is season 2, right?
This is season 2, yeah. this is we are into it, over a year of doing this. Well into it now. I think a couple episodes into it. So it's been a while. Feel free to introduce yourselves and let us know where you're from in the chat if you would like. We've got some folks from Calgary and Saskatchewan and Thunder Bay and Brighton. A reminder that if you are in Montreal, hi Heather. A reminder that if you want to talk to everybody, just make sure to change the little bar in Zoom to say all panelists and attendees and not just Chris and I. We are happy to chat, but if you want to talk to everybody else.
Yeah, lots of cloudiness in the Southern Ontario, but that's okay. Well, we're going to get everybody equipped with info for when it does clear up.
I can't wait. We've just been, of course, for those of you who are joining for the Moon at Noon, we've been working on the Explore the Moon observing program in that show, and I've been so ready to go out and practice and can't see anything because it's been cloudy. Yeah. So hopefully
the forecast for Saturday night or Sunday night was promised to be clear, and I had the right phase of the moon to finish the Isabel Williams program. I had 11 things left and that was the perfect phase of the moon to catch that. And then it didn't get clear here at all night long.
Oh no!
So now that I have to wait a month or whatever to figure out the next one. But anyway, that's not why we're here today.
That's not why we're here. We're here to talk about satellites. And the various things unnatural things orbiting the Earth.
That's right.
And how to find them and how to plan to see them. I was chatting with Alundria, the editor of our magazine, the other day, and she saw a Starlink satellite for the first time go between Mizar and Alcor in the Big Dipper, which she managed to look up on one of the websites that we're going to talk about today.
Very cool. Yeah. All right. Well, you think we're ready to go?
I think we're ready to go. We're 1 minute past our time.
So obviously, we're going to talk about satellite. The moon is a natural satellite of Earth, of course, but we're going to get into the artificial one. So the first artificial satellite was, of course, Sputnik 1, launched in October 4th of 1957. It was actually the impetus for the formation of NASA, among other things, right? It really was a game changer in space.
I just remembered as you said that I have a shirt with Sputnik on it. I could have worn a space shirt today.
Well, we could have a commercial break if you wanted to go.
Run away and change it.
So Sputnik means satellite in Russian. It was a 58 centimeter sphere, not too big. It had a 65-degree orbital inclination. So a 0-degree orbital inclination would be around the Earth's equator, and a 90 would be polar. So 65 is in between the two. And as the satellite orbits on at that angle, the Earth rotates underneath it, and then it gets to see the surface of the Earth continuously, new locations on Earth. And we'll get into more of that in a bit. So nearly the whole world, the habited world, got Sputnik overhead. It was transmitting these beep beep beeps that you could pick up on your amateur radio signals. The batteries lasted 3 weeks, and then it stayed in orbit for, I think, 3 months, and then gravity burned up with gravity when it came down. And that launched the kind of the space age, if you want. So I'm going to get into sharing some resources, and Jenna, you can post these into the chat. So what a really neat website to look at is n2yo.com. It's a sort of a king of satellite tracking websites. And as of today, it's tracking, I think, 22,871 orbiting objects above the Earth. So that's a combination of active satellites, defunct satellites, bits and pieces of things that were launched and are left to tumble around. Thankfully, we don't get too many instances where something hits a satellite and blasts it into pieces, although it does once in a while happen. But nothing like the movie Gravity is expected to really happen to us. There's a running tally. If you go to the website, don't go now, but go later. When you look at that website, they have a counter that ticks over and it's indicating how many satellites are above your horizon at the present time.
That's
And
cool.
just dipping in and looking every now and again, it looks like around 2,300 objects are above the horizon at any given time for somebody.
Huh.
And that may vary at night. I haven't checked them at night to see if there are more, but that's roughly the number. So that's a lot. And of course, the number is growing daily, almost daily. Do things do fall down and get taken out the list, but I think more things are getting launched and added. We'll talk about that in a bit.
And I'll mention one of my friends is who builds satellites for the University of Toronto is launching their satellites tomorrow with Arianespace. But they're microsats. They're little tiny things.
Yeah, I was just going to say, so the biggest thing in orbit, artificial thing in orbit, is the International Space Station. I'll give you some facts and figures about that in a bit. And then the smaller end of the scale are the CubeSats, like your friend is going to launch. And the standard CubeSat has been adopted to be 10 by 10 by 10 centimeters. And those can unfold with, solar panels and things like that. But the basic electronics box or bus is about 10 by 10 by 10. So let's talk about some basics, right? So satellites do not have lights on them. There's nobody up there to enjoy the lights. There are no planes to need to see lights on satellites. And even if there were lights on it, they're far too far away from us to see them, from Earth anyway. So they don't have lights on them. What we're seeing when they cross the sky is sunlight reflecting off the metallic parts of the satellite. And the reason you can see them is that even if the sun has gone down where you are, something high above you is still high enough to catch the sun's light. It's just the same as if you're, in the mountains and the mountain peaks still got the sunlight, but you're in the valley and it's getting dark. So they're a function of being able to catch the rays of the sun and reflect them back down to you. Now, that's why the satellites are more common after sunset and before sunrise, is because they're catching the sun that's just recently disappeared or is just is almost about to come up. At midnight, when the sun has basically got the bulk of the Earth between you and the sun, then the patch of sky that's actually blocked or free of sunlight, nothing can get sun that's above you, is bigger. And so there's sort of fewer satellites that are going to catch your eye in the middle of the night. Let's see, what else have I got here? There are satellites at different heights above the ground. So we have low Earth orbiting and then high Earth orbiting. The ones that are closer to the ground have less opportunity to catch the sun, but they're also brighter when they do. So we tend to see them. They're also the ones that move a little faster. You can, if you're out just sort of relaxing, maybe watching for a meteor shower or something and noticing the satellites, you can actually detect the edge of the Earth's shadow in space. It's a big round zone, by watching the satellites that disappear as they enter into it or that reappear when they exit it. So that's a sort of pastime.
Watch enough of them and you'll be able to kind of see.
If you see enough of them. And, most of us are too busy looking at our, our targets to do that. But sometimes you can just sit there for 10 minutes and just watch satellites, and you'll see lots. Now, the brightness of a satellite is going to depend on the surface area or the shininess of the sun that it can catch and reflect down to you, and its distance. So as I said, if it's farther away, it'll be a bit less. Most satellites will give you a steady light. Now the background behind Jenna, you see the dashed line. That dashed line is because somebody's taken a series of exposures and composited them together.
That's just bad compression as well. In this case, if you want to see the one.
But often you'll see a background where you've got a dotted line, and that's because it's a frame, it's a frame, it's a frame, it's a frame. Yeah.
That one.
Yeah, and there's a gap in between when the camera has to store the picture before it takes the next one. The one behind me is taken by Bill Longo with the Aurora and the satellite. He actually went to the effort to stitch all the frames together and to fill in the gaps to make that nice trail.
I did that with the one that had gaps in it, but I always felt like I was lying and that people would call me out for it. But I guess it really happened. It's just that the camera didn't notice it.
Well, and you're recreating what you would have seen, although you wouldn't see the streak, but you saw it continuously. But that brings me to my next point, and that is that even though they're generally a steady light, so it could be a steady dot that crosses the sky. It can brighten a little bit as it as it exits Earth's shadow, or it can dim a little bit as it enters Earth's shadow, but it can also fluctuate in brightness or go off and on in brightness, usually on a long time scale. And what you're seeing there is something that's tumbling.
Mhm.
And then the shiny section aims towards you and you'll get the light for a moment, then it'll go dark. And you can sort of see it go on, off, or on, then off, and on, then off, and take, a couple of minutes to cross the sky. So those are neat. If you see something flying across the sky that's blinking steadily, continuously, it's an airplane, not a satellite. All right. So let's see. I'm going to talk about, let me share my screen. I'm going to go into Stellarium here and show you how you can use Stellarium to talk about satellites, and then we'll get into some of the types. So let's do this and share. And let's go full screen to do this. So the tip, I'll give you the tip, the instructions for being able to see satellites using Stellarium. So what you want to do is you want to go into the configuration window, F2. You want to go over to the tab that says plugins. You want to look for the one that says satellites. You want to make sure it's checked, load at startup. And when you go into configure, you can decide how often the database gets updated. You can decide whether or not to label them, to show them as markers, and to hide the ones that are not visible. So I've done that. So I'm going to say yes to that, close that up. And you can change the colors and things like that. Then when you've done that, you can, if you want to, you can save the settings so this will always be true for you. And then when you go down to your toolbar across the bottom, there's going to be one that's a satellite when you've done that. And when you click that on, boom.
Whoa.
You get the satellites.
That's crazy.
And if you have time running at 1 second per second, then you're going to see them moving. All right. So you're going to see some moving and some not moving. So let's talk first about this strip across the middle here. So those are the geosynchronous satellites. So geosynchronous satellites are satellites that are used for telecommunications, and they're designed to be above the same patch of the Earth, the same spot on Earth, 24/7 at all times. So as the Earth rotates once in 24 hours, their orbit takes them around in 24 hours. So they're always above the same location on the Earth. So they're synchronous with the Earth, geosynchronous. And of course, that's designed to be able to communicate with them from the same spot. So you have a satellite dish, you want to send and receive your, your satellite internet, or your Sirius XM radio, or your, other means than that. So that's geosynchronous satellites. These are not naked eye. They're too far away, because this kind of satellite is about 35,786 kilometers from the Earth's surface.
Whoa.
So if you do the math and calculate how fast and how far an orbit has to be in order to match the Earth's rotation, that's how far away. 35,786 kilometers away.
Crazy.
Yeah. So this type of satellite is pretty dim. As I said, you can see them in your telescope, but they're not doing much in the way of moving around, except, let me just bring up one here. So you can see that, put this away for a second, that they actually form a band left and right here. And that band is actually because they're on the celestial equator. But the problem is that from Canada, when we look south, Stellarium plots the celestial equator here, but parallax is causing us to appear, those satellites to appear to be below the equator. But if I take us to the equator, so here's my star one. Let's see, this is the Thornhill one. Just turn these buttons on. So I'm going to choose one. There's a geosynchronous satellite. And if I take us to the equator, now it's right on the celestial equator. Yeah. So from the Earth's equator, they'll be right on that line, and from the north, they'll be a little below it. From the southern hemisphere, they'd be a little below it. Now, these satellites actually drift a little bit. They actually form an analemma around the celestial equator. If I speed time up here, let's see if I can make this happen. Watch, you can see Oops, let me just bring this slower a little bit. You can see the satellite is drifting up and left and right past the celestial equator. So in 24 hours, they do this, this trip, this analemma shape with respect to the celestial equator, just to keep them in the right spot. So let me just bring this back to Canada. There we go.
We've taken pictures of geostationary satellites by pointing the telescope in the right part of the sky and then turning off the tracking. And all the other stars move and the geostationary satellites don't.
Exactly. Yeah, exactly. So there's your clue. Yeah, so if I were to say, if I were to advance the time in Stellarium here, you'd see the constellations all drift west, but the same satellite would stay in place because it's following the equator and staying above us all the time. So this is kind of like our satellite that's shining over, you know, the southern sky in Canada, one of the ones we use. So thank goodness that this geosynchronous strip of satellites, and by the way, there are actually people, organizations that designate your parking spot along the celestial equator because there's only so much room. So you have to basically buy or license your parking spot along the equator, because you can't, you know, if you're above it or below it, then you don't get that benefit of that orbit and the accuracy of staying in place. So they pay attention to that. So yeah, so thank goodness that for us in Canada, the celestial equator doesn't ruin our view of some of our favorite objects. So I noticed that I look up my time here. Whoops, let me close this. Go over to here and bring up my clock. Do 5. So if I change the date, you can see that the celestial equator is sort of marching along through the constellation. So I made a note of it, and I figured out that this band of satellites is close to Messier 48. It's just below the Orion Nebula, just below. It'd be in the same field of view in a low power eyepiece. Near the Wild Duck Cluster M11 and Messier 10. But the way you can avoid, you know, having them bother you is that you might notice that they're actually, let me just bring they're actually more noticeable on the side of the sky where the sun is either coming or is left. So you can kind of minimize their effect on your view that way.
By taking pictures, you're observing as far away from the sun as you can on that line.
Yeah, I mean, they're far enough away from the Earth that they'll almost always catch the sun, but there is some benefit you can get from doing that. Yeah. Let's see. The signal delays, they're so far away that there's about a 1/4 second delay to communicate with these satellites. So, and obviously they're not very good for communicating with the Arctic, because in the Arctic, the equator is near the horizon, so they're not too good for that. And let's see, I think I had, so an example of a set of these would be the National Oceanographic Administration, the NOAA GEOES satellites. Those are the geostationary operational environment satellites that are used to help monitor Earth's weather.
Is there,
so that's a bit about
there's no way to have geostationary or geosynchronous satellites above the North Pole or something like that to be able to get, or above the South Pole?
No, because
it's not orbiting.
They are orbiting. So they have to orbit at the same rate that we
Yeah.
turn. So the only place you can do it is on the equator.
Interesting.
Yeah, but there is a trick. There's another kind of satellite that I'll tell you about in a bit that gets around that somewhat. So the next set of satellites would be the medium high satellites. And those ones that do drift around the sky at a modest rate. You can see they've got some here kind of drifting around a little bit. So those are up around 20,200 kilometers above the mean sea level. And they are designed to pass over the same location on Earth every 12 hours. And that would be the 31 GPS satellites are in that class. And they're spread out in a net. I'll show you a diagram of a net. I've got a picture here. Let me see if I can bring up this diagram of the GPS system. Here we go.
Cool.
So you can see that they're drifting slowly around the Earth like a network, and that as our GPS receivers and our phones and our cars and things lock onto and then pass off different satellites as they appear over the horizon.
And those
Right.
GPS satellites, there are not like where the numbers of those aren't increasing, are they? They're up there, and we only need the ones that are there.
Yeah, so they're designed so that their geometry does their work.
Mhm.
There are alternate networks of satellites for navigation. For example, Russians have their GLONASS system. And so if you're looking at the labels in Stellarium, you'll find GLONASS, you'll find other names. Galileo, Europe has a Galileo system. China has Beidou, which is, by the way, Beidou is Chinese for Big Dipper, if you're
That's
interested.
nice.
India has the IRNSS system, and Japan has the QZSS system. So when you watch your Stellarium and you're seeing things drift around a little bit, you can pick up the names. There's a Beidou one up here in this view. There's a GPS one up here in the view. So again, these ones aren't really naked eye satellites. They're pretty far out. But if you're looking at an object through your telescope, a GPS satellite or something like it will cross the eyepiece, a 1 degree field, in about 2.5 minutes. So that's how long it'll
Oh wow,
last
that's
as it
slow.
goes through view. Yeah. So it can contaminate your astro images, but typically you can reject the frame that has the satellite passing through it. Should be okay. Yeah. So about 2.5 minutes to cross that, and you can demo that in Stellarium just by picking a star, putting a 1 degree field, and then watching the satellite, the time it takes for it to drift across. It's pretty easy. All right, then the rest of them basically are the low Earth orbit satellites, the LEO satellites, if you like. So those are the ones that are designed to be close enough to the Earth to keep a good eye on our weather, or our shipping lanes, or various things that are kind of dynamic and need detailed look, and or they're too heavy to lift into a high orbit, and so they place them in a low Earth orbit. And those are the ones that you see, the bright ones that zip across the sky. Those are the low Earth orbiting satellites. And they'll cross a 1 degree field of view in your telescope eyepiece in about 6 seconds.
Much faster.
And that's a 1 degree eyepiece. If you're magnified, if you're looking at a double star and you've got a telescope magnified, it'll be quick. But yeah, within seconds. So they fall into a distance range. So they're designed to be high enough not to get too much drag from the Earth's upper atmosphere while still staying relatively close to the Earth's surface. But they're also, so that would be around 300 kilometers above the surface, above the ground, out to about 2,000 kilometers above the surface. And that's to keep them inside the Earth's Van Allen radiation belt, the protective magnetic field around the Earth. So that's a good place for them to be. And that, of course, includes the International Space Station is in that low Earth orbit view. So given their height above the Earth, they take between 90 minutes and 225 minutes or so to complete an orbit. And those would include, the ISS, the Hubble Space Telescope is one of these. China's Tiangong-1. It's an uncrewed space station right now, but I mean, there are plans to occupy it, I think. The NOAA weather satellites, the Landsat that we get our Google Maps imagery from, the Iridium satellites, the pager network, and Europe's ENVISAT, environmental satellites.
Sorry, Chris, when you say the pager network, do you mean pagers like the beep beep things that happened in the 90s?
Yeah, the beepers. Satellite, now they're kind of satellite phones instead, but basically, yeah, pagers and satellite phones.
Wild. Okay, so I wasn't around for much of the pager time, but
yeah,
I had no idea that it was satellite based. That's so cool.
So that's what the Iridium system was for pagers and satellite phones.
That's so cool.
Yeah, beepers. Other famous ones would be the Atlas Centaur boosters that get left adrift in space once they launch their payloads. Russian Cosmos, Breeze, these Breeze rockets, things like that. Now, the Hubble Space Telescope, I've seen it. It's tricky Let me just bring this up to here. So the Hubble Space Telescope's orbital inclination is only 28.5 degrees. And that means it's very southerly. So it's not very often that you can see it in Canada. So here's a pass just above the southern horizon on April 27th at around just before 10 p.m. of the HST, Hubble Space Telescope. Have you heard about the Planetary Society's Light Sail 2?
Oh, I feel like at some point that was like one of those
so
big things that unfolds, right?
They launched one of these big Mylar sails that unfold. So that's been in orbit now for maybe almost 2 years. Can't remember.
Wow.
And they've been working with seeing if they can increase the orbit height above the ground and navigate with it. And it's about 24 degrees. So even though, I'm a Planetary Society member and I get all the alerts for all of the things, it was a big news for them. Canadians don't really get to see it because it doesn't get up high enough for us, but that's another one.
On the note of propellant in space, because LightSail was trying to use light to propel itself higher up into the orbit. Is that right?
Yeah. So what they do is they catch the light when they need to gain some velocity, and that will raise the height of their orbit. And then when it would push against their velocity, then they turn the sail the other way. Okay. So it sort of tacks like a sailboat. Cool. Catch the sun, don't catch the sun.
Okay. And on that note, Heather had a question, which is, do satellites require constant thrust or periodic thrust?
The ones that are at high Earth orbit, geostationary and middle Earth orbit satellites, they're well above the Earth's atmospheric drag. So I think they keep their station very, very accurately for a long period of time. A lot of them do have thrusters and fuel on board for orientation, and maybe the occasional thing. But the low Earth orbit ones, they do experience drag from the light density of air at high elevation, high latitudes, high elevations, and do need help once in a while. So yes. All right, let's see if I can find you ammonia.
And while you're doing that, Jocelyn, I see your question about the James Webb Space Telescope, and I have an answer for that, but we'll get to it, I think, unless you're going to talk about Lagrange points. Are you going to talk about Lagrange points?
I wasn't. No, I wasn't.
Okay. Can I talk about them then?
Sure.
Okay, so the James Webb Space Telescope is really cool and also terrifying because there's so many things that need to happen out in space for it to work. There's 72 things that need to unfold for it to work. And it's not going in an orbit around the Earth, it's going in an orbit around the sun. It's lining up, as far as I know, with Earth's orbit at these points called Lagrange points, where it can keep on chugging along consistently at a specific distance from Earth, orbiting with us as we go around the sun. Is that right, Chris?
Yeah. So if you do the kind of the three-body problem, if you look at the sun as a gravitational attraction, the Earth as a gravitational attraction, and the satellite, there are places where you can get the forces to null out, and those are called the Lagrange points. And so one of them is it's sort of intuitively obvious, is that if you put something between the sun and the Earth at the right distance, then the tugs will zero out. There's another one that, as you say, happens to be on the outside of that line, joining the sun and the Earth. Let's see if I can find a diagram.
And I will also mention that this is particularly ambitious and interesting because the Hubble Space Telescope is in low Earth orbit. And so when there was an error or a problem with it, and I think it was a mistake in manufacturing, something like that, shuttle launches were sent up to fix it. We can't do that with the James Webb Space Telescope because it's really far away.
Yeah. So if you're looking at this diagram, the sun is in the middle, the Earth is the blue dot. And I know it can be dizzying, don't watch it, but all these numbers are the L numbers. So L1 is between the sun and the Earth, L2 is beyond. So that's where the James Webb will be. And I don't know, this wouldn't be precisely to scale, but you get a sense of if this is one astronomical unit, the radius of the circle, then you can see that L2 is a considerable fraction of the astronomical unit. So it's not something we can easily service.
It's beyond
soon.
Yeah, it's beyond where the moon is. And so that means that we have never gone that far before as humans.
Yeah.
Which is very exciting and cool. I mean, it's just like, it's so exciting because it's like the forefront, it's like the cutting edge of cool space things that are happening. But personally, as someone who is not responsible for fixing the James Webb Space Telescope, I am relieved, but I am stressed for the people who are responsible.
Well, you have to think that it won't be that long before we do have the capability of doing some interplanetary trips of some
Yeah.
sort. Maybe, I mean, but it hasn't been designed the way the HST was designed for humans to go up and swap out parts and things like that. But yeah.
Very
So
exciting.
so technically it's a satellite of the sun. So it's not something we're talking about today, but it is an artificial object in the solar system. So I wanted to talk briefly about these Molniya satellites, which you're seeing. I've got one selected here. So the Molniya satellites, it's a Russian word for lightning, and they're designed to deliver telecom services to high latitudes. So polar or subpolar latitudes. Russia comes to mind, Siberia, places like that. And they do a really, really cool trick. So they're in a high eccentricity orbit. So they spend some of the time very close to the Earth's surface, and then they do a long looping apogee far away from the Earth.
Like a comet.
And yeah, well, so Kepler's second law, right, says that when an object is close to its orbiting partner, it moves fast, and when it's at apogee, its farthest point, it moves very, very slowly. So what these Molniya orbit satellites do is they're on those orbits where when they're at apogee, they spend a very long time moving slowly across the sky when they're at apogee. And then when they're sort of finished, they do a quick pass of the Earth and then they head back out again. So that's where you can see that the Molniya here is up near the zenith, near the Big Dipper. If I advance the time, you will see it is moving through the Dipper a little bit, but slow compared to the other satellites. So, but we could probably select, if we wanted to go to the effort, we could go to a time in its orbit where it's near perigee, where it's moving rather quickly. And that's what they use. So
when it's in perigee, when it's moving quickly, would it be moving quickly over Russia, or would it be moving quickly on the other, like on the south side of the Earth?
Exactly. It's designed to be slow when it's over Russia and fast when it's elsewhere.
Cool.
Yeah. And, Southern Hemisphere countries, the Antarctic could do sort of a similar thing as well. So that has a period of a half a sidereal day, like a 12-hour day. 718 minutes, I think it is. So yeah, so that's the Molniya. All right. So I think we could switch over and talk in some detail about the space station, unless you've got questions. Does anybody have any questions?
There was one question just about the fate of Hubble. I actually don't know what's going to happen to Hubble over time. Do you know?
So Hubble has thrusters on it, and it has flywheels that are used to aim it. So rather than use a burst of gas to reorient the telescope, they just put the brakes on the flywheel, and that transfers some angular momentum to the spacecraft, so the whole thing will turn and aim properly. And over time, the gyroscopic flywheels are mechanical, so they fail. So right now, I think Hubble is down to perhaps they can't afford to lose another one or something before they can't point it anymore. So they're kind of on borrowed time.
Aww.
So they start out by they build them with multiple flywheels so that they can afford to lose a few along the way as they wear out. So I believe Hubble is down to its last set of working gyroscopic flywheels. And if they lose one, then they get into the point where it becomes a telescope that will track a swath of the sky relatively well, but have limited pointing. And then I think at some point they would lose all control, all aiming ability. And at that point, it's no longer of any use. So.
Okay. And Alendria from the editor-in-chief now. Sorry, I almost got your title wrong, Alendria. Alendria is in the chat with details from an article and a link to an article in Sky News as well. So there's some more information there. I also wanted to mention just in general about fates of satellites that I believe there's legislation in place that requires that satellites deorbit themselves within 7 years now, I think. Whereas before there wasn't such a legislation. And so there's a whole bunch of old satellites just hanging out up there. But now once you hit the end of your mission, you have 7 years to get your satellite to fall back into the atmosphere of Earth and get rid of itself, which is a method of decreasing space junk.
Yeah, it makes sense. And there are actually studies underway, engineering test studies of satellites designed to go up and corral and collect satellites and either, and deorbit them.
That's very cool.
I think recently there was a story about a Japanese experiment that was trying to do that. But yeah.
Cool.
Yeah, it's something we're going to have to definitely deal with.
Yeah, it's a bigger and bigger issue. And
as we'll talk about at the end of the session when we get into Starlink.
Yeah, getting into everyone's favorite topic. And then question from Jean-Marc Caron, which we answered at the beginning, but you may not have been here, which is approximately how many satellites are currently in orbit? And the number that Chris added was 22,871 are being tracked by the website that we linked, N2YO, which is pretty close to accurate, I would guess, eh?
Yeah, it's the if you Google how many satellites are there, you get a wide number of answers, but that seemed the most reasonable for it's more in line with what, say, NORAD would have to be, watching for planning launches and for keeping us safe, right? Mm-hmm. So it's a big number.
One last quick question it's not that quick. From Jeff, which is how much does NASA or SpaceX have to worry about traffic on its way up to the ISS or beyond? And I believe that they have systems in place that keep track of every little bit of space junk in case they do have to make adjustments.
Oh yes, yeah. It's all part of the flight planning process. Definitely, they have to make sure they have a window. And I believe there was a close call a few days ago with the Crew 2 that they had to go into an alert mode where there was potential of, I think it was a relatively low risk of an impact with an orbiting piece of debris. But
they're given a risk window, and if it's like a high risk thing, then they have to wear their suits and go into the escape capsule, like the Soyuz capsule, I guess, or maybe not Soyuz anymore. I guess now it's Crew Dragon, to get ready to escape if there's a problem like that. But also remember that we're talking about three-dimensional space, and unlike if you're looking at, cars and pedestrians, which is on just like a flat plane, there is a lot more room for movement. And so there are more easier paths through things because you can make adjustments, like changing the angle slightly in order to get through and avoid certain things.
Space is definitely big, but don't forget that the obstacles are moving at the same time.
Yes, and in different directions and at different speeds, and also they're different sizes. And some of them are even things like the size of flecks of paint cause issues on the ISS when they move as fast as they're moving in space.
Yeah, so I'm gonna share some numbers about that kind of thing here in a second. So yeah, space station. Let's talk about that for a bit because it's one of the easiest satellites that you can reliably see and predictably see, and it's accessible to everybody because it's so clear and obvious. So the first piece of the space station was launched on November 20th, 1988 by the Soviet Union. And it was named Zarya. So Zarya, the Zarya module, which means sunrise in Russian. And so when you're using an app like Sky Safari or Stellarium, you may find that if you search for the ISS, you'll get the name Zarya comes up. That's why. Because it's sort of the core piece that everything else was attached to as they assembled the space station. Right now, the ISS is about the size of a football field, including the end zones.
Whoa.
And that includes an acre of solar panels. And what you hopefully have noticed, and if not, I suggest you go and look at YouTube, look at some videos. The solar panels rotate to face the sun. They keep the sun facing the sun. So as it crosses the sky, they'll be rotating to keep that angle. So they want to catch the sun face on if you can for efficiency. The space station is the brightest artificial satellite, but its brightness varies by a lot. And that depends on whether you're seeing it when it's relatively close to you or off in the distance, and whether it's, catching the sun with lots of the solar panels or, kind of a glancing blow, that kind of thing. So it does vary a lot. It orbits about 422 kilometers above sea level. Actually, the range is between 418 and 422. So that's very circular if you think of it. The density of Earth's atmosphere is not zero where that is. So
technically it's not in space.
Yeah, well, it is in space, but Earth's atmosphere peters out as you get farther up, and it does take a while for you to escape it altogether. So there are actually still 3 times 10 to the minus 12 kilograms per cubic meter of air up there. So it does, these atoms, these molecules and atoms of Earth's atmosphere do hit the space station and do slow it down through friction. And so it does need the odd boost to raise its orbit up a little bit. In case, maybe it wasn't obvious from the beginning, but the faster something is going, the higher it is in the sky. So the geosynchronous orbits are so distant from the Earth, but they're also moving incredibly fast. And the low Earth orbit objects are less high, so they're not having to move as fast. It's just like if you took, put a tennis ball inside a piece of pantyhose and swing it. The faster you swing it, the longer the hose will stretch. And so if you think of that hose stretching as being a higher elevation above the ground, that's the sort of same principle.
And that's counterintuitive, because the ones that are further away are, to our eyeballs, appearing to move slower because they're so far away, but they're traveling faster than the ones that are closer and seem to be moving faster.
Yeah, it's all about the angle they appear to move, the angular rate across the sky versus their orbital rate that they're flying, that they're moving.
I guess you could also, I already revealed that I wasn't around in the age of pagers, but if you had an LP and you have like the needle is moving faster at the edge of the LP than it is in the center of the LP of the record, right?
Yeah,
Is this further up?
yeah. It varies as you go into the middle of the data rate, if you want to think of it, the bumps in the record vary from the edge to the middle.
There's a Calvin Hobbes
now,
like that.
Because of all of these sort of effects on the space station and other satellites, the predictions on when you see it do vary, and the farther in the future you look, the less accurate your prediction will be and generally in terms of the space station, by seconds, or maybe up to a minute. So if you're sort of saying, well, I'm going on a vacation this summer and I want to know if I'll be able to see the space station fly over the cottage, in 2 weeks, you can look it up. But by the time it actually happens, it's going to be different by a minute or by some seconds. So it's best to check as close to the time you're planning to look as you can. We'll tell you how to do that in a bit. So the space station is actually traveling at 7.66 kilometers per second, or 27,600 kilometers per hour, giving it an orbital period around the Earth of 92.69 minutes. So on a clear night, if you catch the space station right after sunset and the geometry is right, you can see it again an hour and a half later and again an hour and a half after that. Generally 3 passes is about the limit. And some of the passes will be right over you and the other ones will be above the horizon as it sort of sweeps across.
And it kind of like looks like it transits the sky. Like one will be over in the west, then it'll be in the middle, then it'll be in the east, or something along, or vice versa.
That's because the orbital inclination, as we talked about at the beginning, for the space station is about 51.6 degrees above with respect to the Earth's equator. And so that it's sort of flying like this, and the Earth is turning underneath it. And that means that it's constantly seeing new strips of the Earth, if you like. The range of sort of north to south would be between the Falkland Islands and the Kamchatka Peninsula in Siberia. That's as high as it goes. So it would never fly over the North or South Pole, for example. It'll pass over the same spot on Earth every 3 days or so. But when that happens varies. because of the, the rate that it flies around. So the rule of thumb is that it'll be over your house every 63 days at the same time of night, give or take.
Okay.
So you can kind of use that as a prediction. It doesn't need to be straight overhead to see it. It can be to the east or to the west, as Jenna said. So what else? Yeah. So the higher passes, the more the ones near the zenith, generally take longer beginning to end. So they can be up to 6 minutes, 7 minutes in some cases, by the time you first glimpse it to when you lose it again. It does depend a little bit on where the sun is by then. So you can lose the space station into the Earth's shadow and it'll become not visible to the unaided eye. So that can limit the view. I'll show you some satellite pass sky charts when we get to heavens above. You can see what I mean about that. Yeah, and the ones that sometimes the space station just comes up and skims the horizon, and that might be only for a few seconds or a minute. So when I'm doing my skylights on Sundays, I don't generally list the space station passes where it's below about 15 degrees maximum, because there are trees and buildings in the way and they don't last very long.
I will link Chris's skylights in the chat as well.
So I showed you how to set up Stellarium to show satellites, and when you're done with them, if you want, you can just toggle them back off. So they don't have to be always there in the way of your favorite stars and deep sky objects, but you can summon them when you want them to. The neat thing about Stellarium is that when a satellite is catching the sun, you'll see a symbol, but when it isn't, it'll be dark. So for example, I'll do it with the space station here in a minute. So I've got a pass of the space station. And if I wind this back, if I go back. Okay, so it's visible there, visible there, visible there. At some point, the symbol will disappear when it gets. Space station's so bright, it doesn't work that way, but you'll notice that if you pick a dimmer satellite, there'll be times where the symbol is not there, and then it'll appear, because then it becomes visible.
What's beside it?
Yeah, so I noticed that Stellarium's got a couple of different objects or items associated with Zarya, and I don't know why there's a gap. What I did is I went into the settings and I updated the orbital elements, and they got closer together, but they didn't merge. So I'm not sure why that is. But if you search for ISS, you get the one, and then you've got the partner. I have seen the Dragon capsule chasing the space station across the sky, though.
That's cool.
It was cool. Unfortunately, when that happens to you, you don't have time to get on Twitter. But if you've got neighbors, you can yell. So that's what I did, is I yelled at the kids across the street playing basketball, and they said, "Oh, that's cool." And I WhatsApp my daughter. She saw it too.
And I guess it would be around, because it'd be around the launch time or right before they dock, I guess. So watch NASA's Twitter or social media and see when the crews launch, and then look up like a day later and see if you
look up your passes, and you're almost guaranteed to see the twins, one bright and one dimmer, either leading or trailing. So it depends on how it's working. I think in the case when I saw the Crew Dragon capsule, it was leading the space station at the time I saw it.
Cool. Also, shout out to Wayne, who said that they got a photo of that, and that's cool.
Nice.
Yeah.
Nice. Now, if you see a satellite and you want to look up what you saw, there are tools to do that, but you need to know the time you saw it pretty accurately. It can't be around 9:30. It's got to be at 9:27 if you really want to have a hope, because there are so many satellites in the sky. You really want that accuracy. It's also, a good way to rule out UFOs, things like that, because you can look up what they were. And you've got a story about somebody helping you.
I do. Can I tell it now?
Yeah, go ahead.
Okay, so this was great. We had, and we may do this again, we had an online observing night on the Perseids last year. And we all hopped on our RASC Discord, which is a little defunct right now, but we might get it back going again. The Discord channel being an audio channel. So we were all chatting with each other and talking about what we were seeing. And Chris was there and giving us all tips on what to observe. And it was fantastic. And Eric Briggs, one of our board members, was on the phone too. And we were sitting outside. I was out in our various different places across the province. And it just so happened, or across the country really, it just so happened that that particular board member knew where I was. And I said, hey, there's something really bright in the sky, but it's not the ISS, because I already checked for the ISS passes and there weren't any. And he said, oh, where is it? And I said, well, it's coming from the west and it's going east and it went right through the summer triangle. And he looked it up and he was like, oh, that was the X-37B space plane from Boeing. And it was the coolest, like, honestly, that of my astronomy career, after like those inspiring first moments of when you first see the Andromeda Galaxy and all that sort of stuff, that was like the highlight of everything. It was so cool that you could like tell someone what you just saw and then they went on the internet and figured out what it was for you. And the fact that it was Boeing's secret space plane, which is the next iteration of the shuttle, more or less. Yeah.
Well, it's uncrewed.
Yeah.
They say it's uncrewed. It goes up and spends months at a time in orbit, but it does look like a space shuttle. So here's some pictures of it.
It's like a space shuttle without the windows, which I think looks so silly because you're so used to being able to look out the front of a thing that looks like a plane, but
and it's smaller.
It's just so cool. So you can, when we get into Heavens Above, you can see how to find that information there.
Yeah. So I don't know if you've realized it, but I've had this ISS pass going in real time, and you can see how long it does take to cross the sky. All right, so let's talk a little bit about what you might see in the eyepiece around satellites. So I mentioned the various rates that they pass through your field of view, depending on the type of the satellite. But when you're observing, and this is true in any case, not just for satellites, but do spend a good deal of time looking through the eyepiece, good stretches of time, because you're waiting for the seeing conditions to stabilize and you get that sharp, crisp view of the planet or whatever it is you're looking at. And that will also greatly increases the odds that you're going to see a satellite go through at the same time. And I don't think there's ever been a time when I've been out on an observing night and I haven't seen a satellite zip through the eyepiece. There are so many of them up there. So by doing those long lingering views, you do increase your odds of seeing the satellite. And that includes the moon. So I saw a satellite go through the field of view when I was looking at the moon a week or two ago, and it had a shape, and it was rather quick, so I didn't get a chance to really see what it was. It wasn't the ISS or anything, but it wasn't just a little speck. It was actually something with an extended shape to it. And I should have noted it and looked it up, but you will get that. You will get that. So,
and I'm going to just quickly mention that when you're looking through a telescope, you see things that are dimmer than you would see with the naked eye. So you see more satellites because of that as well. And personally, I'm most familiar with CubeSats and smaller satellites because I have friends who make them. And those are being sort of like this size to like things that you can hold up with your arms, and you won't be able to see those. Those are too small to see.
Yeah, but with 22,000 objects up there,
there's a lot.
You're definitely bound. You're definitely bound to see them. So yes, that's another good reason why you should take your time when you're observing to look through the eyepiece for a long time. If you want to see the space station magnified through your telescope, you can. I've done it. I have a big Dobsonian that I've used and done it a few times. There is a bit of a knack to it that the more times you do it, the more success you'll have. But what you can do is you could put a low, a long focal length eyepiece, so that'll give you a low magnification and increase your field of view. And that's great because it does move rather fast, and it'll, you can keep it in view more easily if you've got a low magnification. You will see less details, but you'll definitely see the fact that it's got a shape to it, that it's sort of an H shape with the solar panels outside on either side. So that's definitely possible to see with any reasonable backyard telescope at low magnification. The long passes are good ones to use. So the ones where you've got And when I show you in Heavens Above, you'll see that the passes that are 5-6 minutes long that go right overhead, those are great ones. And what's great about that is that if you can catch the ISS when it's ascending or descending or moving horizontally, then you've got fewer motions to do with your telescope, right? So you can sit there and know that it's coming up in the east or west, and you can just sort of basically lift your telescope with it as it's rising up.
Ooh.
And the more times you do it, the better at it you'll get. Some go-to telescopes could track the ISS. I had a telescope that theoretically could do it. I never really tried because I didn't want to waste my observing night on getting the space station, but you know, you can do it. We've done it with the telescope at the CAO, the Car Observatory in the Toronto Center. We have a Paramount with a 16-inch scope, and last time we were there, so summer before last, we did watch the ISS through that. That was cool.
Cool. Also, shout out to getting a RASC membership. If you're a member of Toronto Center, they do have an observatory in Collingwood area, and several other centers across the country. If you are not a RASC member, several of them have observatories as well.
Absolutely. Now, I'll just see let's see if we can find. So one of the tricks you can use, let me just pause it here, is when you look up the track of the space station, see if it flies close by or across a reasonably bright naked eye object, and then just simply park your telescope on that object and wait for it to fly through. And if you've got a long pass, you can even have a few, stops along the way. If you're good enough at being able to swing your scope around and maybe centering, this bright star, then you might have 2 or 3 opportunities to catch it as it zips through. If you wanted to record, put your camera on your scope and record, then you could get, a good number of frames of the station as it zips through your field of view.
And I'll also mention, because John just posted this in the chat as well, transitfinder.com or transit-finder.com.
My next
Sorry,
point,
Chris.
Exactly. So go ahead and post that link. Yeah, if it's not there already. Yeah, so if you want to see the ISS transit the moon or the sun, that's a good tool to use, ISS Transit Finder. Let's open that one up, and I'll just demo how it works.
It's also for the moon. Again, the moon is a really easy to find object, and if you're in the city and there aren't other things that are easy to find, if you know that the ISS is going to be near the moon, that's another good way to set up your scope and wait for it. Yeah,
absolutely. So once you get the hang of it, it gets easier and easier and easier using these little tricks. So transitfinder.com will either auto detect your location, or you can select it from a map. So I'm just going to let this auto detect. And then you can set the time range, the date range on when you want it to search for, and the distance, the radius around you that you want it to work in. So here's one that goes from May 1st to May 27th. Let's go back to, maybe it knows that there aren't any today, but I'll put today in anyway. So I'll look for the ensuing month within 50 kilometers of North Toronto. Click calculate. And then it comes up with this list. And you can see that we've got, these are only moon passes. Oh, here's a solar one. So it'll pass near the sun on the 29th of April at 10 in the morning. It'll pass right over the moon for me on the 5th of May at 8:30, looks like it's AM, should be AM, yeah. And so on. And what you can do is then you can say, okay, I want to see this, and here's where the trick is. So if you click on show on map, then it shows you a map of your location and the line through which the pass will be visible. And then you can also recalculate for this location.
And it'll give you more detail.
And show on map. Oh. And then if you want to, if you're allowed, if there's no lockdown and you're able to travel, you can find a spot where you can set up and get your video of the ISS transiting the sun through a properly solar filtered telescope, of course. Now, the passes If it's across the middle of the sun, it's only about 1.1 seconds, edge to edge.
Speedy.
If it's a glancing blow on the edge of the disc, then it's even shorter. So if you park yourself near the edge of the zone, you're going to get a very short transit across near the edge. If you're on the center line, then you get the maximum length of time. And this will tell you the exact time and the height in the sky and all the various things. So let's go back. So that's the sun one. Here's the one that's the lunar transit. And of course, the lunar transit, you don't need any special equipment. Anybody who has a telescope that shows the moon can use this. So here's one that's all the way from Oshawa up to almost Georgian Bay here. And if you've got a cottage or someplace you're allowed to be in the next little bit, there's your chance. And this, you can even get down to street level or park level on a map like this.
When is that?
Exactly where you
May
need to be.
5th?
Yeah.
All right.
So a lot of times the rascals will, look this up. I don't remember to check all the time, but people will look it up and they'll put the alert out to the community. So to say, let's go.
There was a question from the YouTube chat from Vijay who asked if they can see the ISS solar panels or at least some detail with 10 by 50 binoculars. Because you said most backyard telescopes would do it. Would binoculars do it?
I think you'll see that it has a shape. I don't know how much detail you would see with 10 by 50s. But yeah, I think you'll be able to make out that it has a definite shape to it.
That's pretty cool. It won't look like the beautiful shots that people get and post on Reddit, which is what I'm comparing everything to in my mind. So
yeah. I have image stabilized binoculars, which are fantastic. And I haven't tried them on the space station, but that's on my to-do list now that the weather's getting nice again to give that a try.
It's a good idea.
Let's see if that works. Yeah, so transit finder, that's great. So sun and the moon. Be careful with the sun, but the moon is fair game. Anybody can try it. Go for it. And these happen fairly frequently. So, probably every month or so, there's one of these transits. So don't despair if you get clouded out or if you, miscalculated and missed it. Try again. Let's see. We can talk about Starlink at the end. Let's look at Heavens Above now. So in terms of where you can look up your satellites, your passes. So I like to use heavensabove.com, but there are some other ones that you can use. The one I mentioned at the very beginning that's tracking the 22,000, the n2yo.com is another option. But this is Heavens Above. This is my usual go-to. And what you have to do in order to get an accurate satellite prediction for you, you need to tell it where you live. And so what you can do is go into the locations, and you can do that a couple of different ways. But I usually use the box up here. So if you click on this box, if you haven't visited the site before and set this up, it'll be like 0 degrees latitude, 0 degrees longitude, or something.
In the ocean off the coast of Africa.
Yeah. But I've set mine up for my home location. And if you want to, you can drop a pin. The more accurate you are, the better. Now, when you're using an app for astronomy, 100 kilometers is fine. You don't need to worry about getting your arc minutes, your degrees, minutes, and seconds for using an app for astronomy. But for satellite passes, the more accurate you can be, the better. So I've gone in and I put in my exact lat long and even my elevation. And you can do that by using like the Where Am I, the right click on Google Maps and things like that. You can grab the latitude, longitude, and maybe there are even some apps where you can do that on your phone. Give yourself a location and be sure to set your time zone. So it gives you the correct, Heavens Above works in local time. So it'll give you your local time rather than universal time. So once you've done that, you can head back, and then you've got a number of fun things that you can work with. So you can do a live sky view. So if you click on this one, this will give you the sky currently overhead. And there's a set of Starlinks that are going by right now for me in the daytime sky. So that doesn't help much, but you could get a live view at any point using this tool. So that when you see the Starlinks in a row like that, it's because they've recently been launched as a cohort, and they haven't yet been distributed around the sky. They're meant to be distributed in a network around the sky so that even different geographic locations on Earth can then provide broadband to the surface of the Earth. But when they first launch, they're usually in a stream.
Because they're all coming from the same rocket.
Yeah, they're gradually separating.
If you watch SpaceX's coverage of it, occasionally, because they have so much money, they can afford to do things like put cameras on the rocket that they've sent up. And so you can watch the satellites be like sprung off into space, which is a very cool process, regardless of whether or not you're pro or anti-satellites. It's just really interesting to watch the deployment of them.
Yeah, so this is the second link. So if you click the second tab on Heavens Above, you get Starlink Dynamic 3D Orbit Display. And this will give you kind of a sense of where they're at.
Neat to see the lines of them there like that. That's crazy.
Yeah, these rows of them. These are, all the different satellites that they've launched. I haven't worked with this much, so I can't tell you too much about it. Then you've got an ISS interactive 3D visualization. So this will show you, where it is over the Earth and where it is, generally speaking. So this is fine. I'll give you another recommendation beyond this one that does a nicer job. You can look up the Tesla Roadster, where that is as well. And then we get into the real meat of it. So this is the interactive the 10-day predictions for satellites of special interest. And so what I do is on Sunday, I head in here to ISS, and this gives me, starting now for a week ahead, the passes that are visible. So even though it's flying overhead every 90 minutes, even in daytime, you don't care. You only want the ones where you can see it. So you just click visible only. And then it gives you the date, and it gives you the peak brightness, and more negative means brighter. So if it's above -2.5, -3, those are really extremely bright and really worth looking for. It'll give you the time that it really first appears or gets sufficiently above the horizon to be visible. Usually it's about 10 degrees above or some number that they pick. It tells you here the altitude that it'll be when it first becomes visible. So 10 degrees would be kind of, it clears the trees and hits the visibility. The ones where the number's bigger, it needs to exit the Earth's shadow before it becomes visible. So it's already quite high before you can first see it. Then it tells you the direction where that's going to happen on the compass. Then it's going to tell you when it reaches its highest point. So the time, the elevation. Of course, 80 degrees is nearly at the zenith. So the higher, the better. The direction it'll be then. And then the trio of information for when the pass ends. So the time it ends, how high it'll be. So in this case, 10 degrees means it's basically dropping too low to see anymore once it's below 10, and the direction that happens and the pass type. And what you do here is you can click on any one of these you like. And by the way, right now the space station for the GTA is in the pre-dawn, but it may be different if you're in the prairies and some other parts of Canada. It may be evening passes. I haven't looked it up. But so here's a really good bright pass this morning at 5 a.m. So that doesn't help us much. The next really good one I found, let's see, there's one here where it's 80 degrees up. So I'm going to click on the date, and it's going to show me a sky map, kind of a planisphere view of the pass. You can see the arrow here shows you the direction it's going. So it's going to exit the Earth's shadow, some here near in Serpens, okay, at 4:29 a.m. And again, pretend this is PM and pretend we're excited, but I'm not getting it related to this one. But I'm just explaining generally how you'd use this. So it'll exit the Earth's shadows. You should be able to start seeing it at 4:29. It'll be nice and high, 45 degrees up. It'll travel through Hercules, right past Vega, star Vega, right past Deneb, and then start descending into the, where is it here? east, northeast. And you've even got some lines. Now, if you wanted to see where it's going to be, you could click on this and it gives you a zoom in. So let's say you wanted to watch it as it flew by Vega. You could figure out the, the field of view given by your eyepiece and work out, whether this would be a good scenario to have Vega, and make sure you work out your telescope's flips. So, if I put Vega at the top of the field of view, that the space station will fly through the bottom of the field of view and work that out. So that's a cool one. You can change the resolution of these charts, and then I usually save them. So I'm doing my skylights. I say which ones are really good. I pick one, and then I right click the picture and I put it on my Twitter when I tweet it. I put the sky chart pass. That's really easy. If the times are local times, they're not universal times. So these are 3 a.m., 5 a.m. and so on. So that's really easy to use. And then if you want to look into the future, so you can click the right arrow. So here's the next week. Bunch more. The next week.
Oh, and it's starting to get into the evening sky.
Yeah. Oh, did you see some at the bottom? Yeah.
Yeah, it's just
yes.
starting there. Yeah.
So right around May 14th, we started getting them in the evening again for me, where I am. So the next really good one would be, that's too low. So an evening one, here's one at 11 p.m. on 14th of May, reaching 65. So if I go back to Stellarium, what was that again? That's 14th of May at 11 o'clock. So I can go to 14th of May at 2300. And there's the ISS. And if I play time, here we go.
There it goes.
Here it comes. So we can watch it fly. So you can use the flat charts on Heavens Above, where you can transfer the information into Stellarium and then watch it dynamically and plan your attack. I've got this sped up, so it's not really moving that fast. That's the natural rate.
There it goes, yeah.
So going back here now, let's go back. So you can look ahead. And as I said at the beginning, the ones that are 2 weeks from now, they'll switch, they'll vary a little bit in their exact times. So let's go back to the main page. And there's a couple other things I wanted to highlight. You can get the Starlink passes. You can get the X-37B.
Yay!
So that's the US Air Force Boeing space plane.
And if you're in Toronto, it's in the evening sky right now. So just saying, pretty cool.
Yes. So heading back to Stellarium here. I'm going to go back to now. And in Stellarium, you won't find X-27B. Its designation in Stellarium is OTV6. So there it is.
Yay.
So that's May 1st at 10:15 p.m. It's going to do a pass for me and us in Toronto, flying basically west to east in the sky.
Was that May 3rd, you said?
May 1st.
May 1st.
At 10:15.
Okay.
And that came from Stellarium. So that should be May 1st at 22:14 to 22:15 in the sky, magnitude 2.1.
It's not as
I don't know what you could see in a telescope, whether it would be worth trying. I guess online you can find people who have photographed it. So
cool.
Your mileage will vary.
Yeah.
But that's how you would do it. Let's see, what else do we have? Korean satellite, Hubble Space Telescope. So if you want to watch for the Hubble Space Telescope, no. So if there are no passes currently in sight, we can go forward in time and see if there are any. No. So I think this uses the 10-degree limit. So as long as it's below the horizon, below 10 degrees, you won't get
Whenever
any.
you're allowed to travel to do astronomy again, travel south so you can see the Hubble telescope.
A couple last things here. So daily predictions for brighter satellites. So if you're just worried about tonight, you can dial in the date, April 2021, the date, either morning or evening, and you can ask it to limit how bright they'll be. So I've set it to the most brightest satellites. And by the way, by excluding Starlink passes, it'll keep the list nice and short. If you uncheck this, you'll get 2 pages worth or something. So this is gonna be a problem. unless you've got the space station passing, then this list is going to be all medium bright objects. They're not going to be negative magnitude bright objects, but you can see that there are a number of different objects that you can pick. Find one. My recommendation is to find one that reaches a nice high altitude and with a reasonably good brightness. And then you can either go out and watch for it, or and then you can of course use this to come back and check what you saw. So if you were out with a friend and you saw something bright and it was, 10:27 p.m., you could dial in the date you were out and you could look for 10:27 p.m. and identify. That's what Eric did for you.
Yeah.
Let's see. That's all I want to talk about for this one. Heavens Above's good. The other one is good. In terms of apps, the apps I like include ISS Detector. And I like ISS Detector because it's an Android app.
Yay.
I can show you a picture here. This one actually lets you, it gives you a reticle. Let me just bring this over a little bit here. So this reticle, when a pass is happening, it encourages you to turn your phone and to tilt it to put the space station image onto the track. And then if you look along your phone, then the space station should be there for you.
Oh,
And
wow.
this contains a library of other types of objects. You could do the Hubble Space Telescope, and other objects in the list. It'll even add comets from time to time.
Cool.
And it'll guide you to where they are in the sky. You can also use Sky Safari. There's the gentleman that created Sky Safari created an app called Orbitrack, and it has a very similar interface to Sky Safari. I'll just show you an example, and it's both Apple and Android, so it's a great one to use. And again, this one will even let you have a view of the sky, where you can see down here I've got modes of viewing. Let me just let this load. So you can view a star map. You can view a view off of Earth and see how the satellites are surrounding the Earth. You can also track where it's flying over and various options. So Orbitrack is a great one as well. Let's finish up just briefly on the future and talk about Starlink. So
go ahead. No, you go ahead.
Well, I was just going to say, for those that don't know, SpaceX is launching the Starlink satellites as a commercial service to bring broadband internet to every part of the globe. And so when I have grumpily complained about Starlink satellites, I've received some pushback saying, "Hey, why don't you want us to get internet from rural areas?" Fair enough. There's if you can share the link in the article, there's a great article on Sky and Telescope magazine that's an online. It talks about the mitigation that Starlink are doing, trying to appease the impacts of Starlink on visual astronomy by putting sunshades to prevent the sunlight from glinting off the satellite surfaces. They want to achieve a magnitude 7 or dimmer goal, which would take them beyond the range of naked eye visibility. So then they wouldn't modify the constellations, if you like. Mm-hmm. They've already been given approval for 12,000 satellites, and they've applied for another 30,000. And that's just SpaceX. Other groups also have proposed multi-thousand satellite constellations.
Yeah, I heard.
In competition.
I was talking to Bell the other day about my internet, and they were saying that they are putting satellites up there now too. Yes,
it's going to get busy. Unfortunately, I think the analogy of the ocean fisheries is a good one, where it's a frontier that's being used or exploited by a number of groups, and that at some point somebody's going to need to regulate just to keep it fair for everyone.
Any young people in the audience, go get a degree in space law, because it's going to start being relevant.
Yeah.
Actually, I have no idea if such degrees exist, but if they do, that'd be very cool.
Yeah, and in terms of the effect on amateur astronomy, of course, you do see the satellites passing through the field of view. they're more damaging when they're still in the process of separating, because then you get a stream of them going across your images and so on. They also transmit radio, so that does affect radio astronomy to some degree as well. So it's not just the optical astronomers. So I'll stop talking if anybody has questions.
So far, not a ton. I just wanted to quickly quote Firefly and say it's getting awfully crowded in my sky.
Yeah.
There's a question from Hernan saying, is this Stellarium Plus? You mentioned, I think at the beginning, that you had just re-downloaded or re-added a plugin or something like that for the satellites. Is that the case?
No. So this is just a recent version of Stellarium off their website, not the paid version. It's just their, I think they're up to version 0.20 point something. But the satellites have been in the software for a while now. So I got version 21. The trick is you just need to go and enable them by going into the configuration, plugins, and I mean, there's lots of different things that you can play with Stellarium, and we'll do a session where we get into some more fun.
Super advanced one, yeah.
But yeah, just go in and configure them. If you didn't catch what I did, just watch the YouTube back. I went through the steps at the beginning.
Yeah. There's a question from Heather. When you were talking about image stabilizing binoculars and observing the ISS, when you're following it along, do the image stabilizing binoculars try to like hone in on a bright light? I always thought they just had motors that made it less hard to jiggle them.
They just take away the jiggle.
Okay.
But it's unbelievably effective. It's really, really helpful. I was trying to see the Lunar X last month, and with the image stabilized binoculars I could, but without them I couldn't.
That's cool.
Yeah.
Also, Alendria confirmed that there is in fact a degree in space law
I'm
at
sure.
McGill. So if you want to go into space law, go to McGill.
That's right.
Other than that, we don't have any questions. If you have any more questions, please send them in now, because we're getting to the end.
Yeah. I think I covered pretty well everything that you need to know to do satellites.
Yeah.
Hopefully you've got a greater appreciation for what you're seeing and how they're moving and the differences. And it's making lemonade out of something that could otherwise be an annoyance. It's still a bit of a thrill to see a satellite zip through your eyepiece.
It's kind of, I mean, like, I know a lot of people do not like satellites, and that's 100% fair. And there are certainly very valid reasons to dislike them, like that they're messing up radio astronomy, and that's limiting our knowledge of the universe. But it is really, it's like a really cool reminder of how far we've come as a species. Like, it's so cool that we have managed to send things up into space that we can talk to frequently, that tell us all sorts of stuff that we now need to survive, but no, non-astronomer human being spends most of their day thinking about this stuff.
Yeah, and we take the GPS for granted. Think about the helicopter, the Mars helicopter. So it's lifting off, it's flying around, but it doesn't have GPS to navigate by. It has to use kind of inertial systems where it's sort of watching the ground or watching the Perseverance rover and ranging and that kind of thing. If Mars will one day, I'm sure, have a GPS style system around it where, humans or our emissaries will be able to navigate the planet that way.
So cool.
It's exciting.
So cool. Oh, so cool. So there's some really cool stuff about it too. And as you say, might as well make lemonade with whatever's up in the sky. Yeah. And bright satellites as well, like the ISS, and no secrets here that I like the X-37B. You can see them from the city. So even if you're stuck in quarantine if you're stuck in lockdown and you can't leave, you can still see some of them, which is nice.
Well, we've had a lot of the Aurora imagery on the Rask National social media. So if you start picking up photographing satellites, really share them. We'd love to see them.
Yeah, we should create a hashtag. We'll talk about the social media team with the hashtag that you can use to share stuff related to the program.
If you do search for imagery of the ISS, there are a number of animated GIFs that people have recorded where the station is moving a little bit. They're cool.
And there was someone who, I don't know if I'll be able to go far enough back in the chat, but someone mentioned that they got two Rask members got photos from two different locations over a pass by the moon, and managed to get like a stereoscopic view of it, which was super.
Oh, that's amazing. That's
fantastic. And it was
fantastic.
published in Sky News. Amazing. Cool. Well, thank you all so much for joining. Next time around, I once again didn't remember to look up what we're doing. Do you remember, Chris?
Roy, I know we have the sun coming up.
Galaxies in Plain Sight before that. We're gonna
Oh
be
yeah,
doing-
so if you've gotten your latest Sky News magazine in the mail, I got mine yesterday. I've got a little article in there that hopefully will give you some hidden gems that you can search for even without a go-to telescope. So you can find some galaxies manually using some markers, nearby markers. So
we're
we'll
gonna
cover
be
some of
talking
those. I want to do a session about misconceptions in astronomy. I have a couple. I'm not going to spoil by telling you my favorite ones, but if you're an outreach person, or if you've done some stargazing and someone's come up and said something that you were surprised by, that they were under the impression, the misapprehension about, let us know. And I'm happy to see if it's something new that I haven't got on my list. And we'll do a session where we debunk all of those things and set people straight.
That's an excellent idea. All right, we'll see you all in 2 weeks. And if you are interested, you are welcome to go to rask.ca/moon@noon to join us for our other program that's happening on Thursdays at noon, as the title suggests, where we observe the moon. This is a good episode to join us for, because we are doing a troubleshooting session where we answer all of your "why can't I see this" questions.
Yeah.
So we'll see.
And don't forget that from starting this weekend, we're into third quarter galaxies again.
Oh, it's galaxy time. Yeah, go and check out those galaxies if you've got clear.
Next week, dark skies.
All right, we'll see you all in 2 weeks.
Keep looking up, everybody.
Clear skies.